we're going to get a little bit more practice here with describing our end behavior, along with a couple other things. We're going to see what turning points are, and then describe the intervals where our graphs are increasing and decreasing. Before that, though, I have right up here our standard form for polynomial functions, and this long, crazy, scary-looking thing is standard form for a polynomial function. Just to kind of break this down, though, so I have a sub n, subscript n, times x to the n power, plus a sub n minus 1 times x to the n minus 1 power. Okay, all of this means is look how the power, the subscript, and the power are related to each other. So if this was like x to the 4th power, okay, the a sub n just means this is my coefficient of x to the n power. Again, this is just kind of a more for an exposure type thing. I don't really expect you to ever memorize what the standard form looks like, just to kind of get you to see how this works. So as you go through some of your math classes later on, you might see some scary looking things like this. But if you notice, your powers keep decreasing until you get right here a sub n, or a sub 1, x to the 1st power. So x to the 1st power, and then your coefficient that goes with, and then a sub 0. This would just be a constant of some kind, where we have a number but no variable to go along. All right, like I said, let's get some extra practice here describing end behavior. And we'll also look at these turning points. Okay, and for all of these graphs, we have arrows. Okay, number 1 here. I have y equals 4x to the 4th plus 6x to the 3rd minus x. And if we look at what our degree is, we have a degree of 4. So that tells us that both of our ends should be going up like what we see here. So our end behavior, just like what we were doing before, we would describe as x approaches infinity. So the further we go to the right, what are our y values doing? They're getting higher. So our f of x approaches infinity. And then as x approaches negative infinity, the further we go to the left, your y values are still increasing again. So f of x also approaches infinity here. All right, now let's describe our turning points. And our turning points we'll estimate a little bit, just because these turning points aren't exact. But turning points are where your graph changes directions. Okay, so I have a turning point here. And I'm just going to estimate this as being -1, -1. And a turning point here. Okay, let's say this is -1/4. +1/4. And right here. Okay, and this looks, maybe it's 1/4, and then halfway in between, so -1/8. Okay, so I have this 4th degree polynomial here that has 3 turning points. Maybe there's a connection there. We'll see later on. Okay, and then we also want to describe where is our function increasing. Okay, so where are our y values increasing? And we read this going from left to right. So if I start at the far left here, okay, my values are decreasing. My function's going down. Then as soon as I get to this turning point, from here to here, my y values are increasing. And then we decrease again. And from here on, and forever, we'll be increasing again. So we are increasing when our x values are between -1, and -1/4. And we're increasing again when x is greater than or equal to 1/4. And I guess really I should say greater than. Okay, so these shouldn't have the equal to option. Because when x is equal to 1/4, that's exactly where your graph is changing direction. So we're not really increasing or decreasing at that point. So these really should just be greater than symbols. Okay, no equal to option. Okay, and then we're decreasing in the remainder of our graph. So left to right, we're going down here, and that is when x is less than -1. And then we're decreasing again right in this little chunk when our x value is between -1/4 and 1/4. All right, so let's look at the next one, number 2. Again, we really have arrows here. Our equation y equals -x² plus 2x. And let's see, my end behavior, okay, second power. My degree is 2, so both ends go the same direction, and they both go down in this case because of that negative. So my end behavior is as x approaches infinity, further we go to the right, our y values, f of x approaches -infinity. And same on the other side, as x approaches -infinity, f of x approaches, well, the further left we go, our y values go down again, so approaches -infinity. And this one only has one turning point here, at 1, 1. And then increasing and decreasing, my intervals are pretty easy here. We are increasing. If we start on the left and work toward our right, we increase, increase, increase until we get to here. So we're increasing when x is less than 1. And then we decrease the rest of the way. We decrease when x is greater than 1. All right, so in this case, we have a degree of 2 and only one turning point. All right, well, let's look at this one. Y equals x to the third. Okay, my end behavior, my degree is 3. I don't have any other terms. My end behavior does what we would expect it to do because I have an odd degree. As x approaches infinity, the further to the right we go. Our y values approach infinity. Further to the right, the higher our y values get. And as x approaches -infinity, the further to the left, our y values are decreasing, approaching -infinity. Okay, and this is kind of weird because I don't actually have any turning points here. If you look at the graph, it's kind of hard to tell, but our y values, our line is really just kind of leveling off. The closer I get to 0 here on the x-axis, my y values are still increasing a little tiny, tiny, tiny bit at a time, just really, really gradually, and then they take off again. So there are no turning points here. And we're increasing the whole domain, so increasing for all real numbers and never decreasing. Okay, because our y values are going up the whole time. Again, they level off, but then they take off again, increasing the whole way. So that's kind of weird. Third degree, no turning points. We thought maybe we were onto something. So let's look at one last equation. Number 4, y equals -x to the third plus 2x. Again, arrows on both ends. And I have a degree of 3 here. this negative in front though, which makes my ends do what they're doing. Okay, my ends go opposite directions, and this right end is going down here because of that negative. End behavior as x approaches infinity. Further to the right, f of x approaches negative infinity. And then the left, as x approaches negative infinity, f of x approaches positive infinity. Our y values are going up here. And right here, my turning points. I see 2 turning points, 2 places where my graph changes direction. And I'm going to kind of estimate these a little bit here. Let's call this point negative 3/4, negative 1. And then positive 3/4, positive 1. Then where are we increasing? Well, from left to right, going down, increase this little interval. So we increase when x is between negative 3/4 and positive 3/4. But then decrease when x is less than negative 3/4 and decrease again when x is greater than positive 3/4. Now, 3 out of these 4 situations, it looked like whatever our degree was, -1 was how many turning points we had. Except for number 3. What's the trick? Okay, here's our rule. Polynomial functions with degree n have at most n minus 1 turning points. So if you had a polynomial function with degree 6, for example, you could have 5 turning points. You could have 3 turning points. You could only have 1 turning point. All of those possibilities exist, but it's at most n minus 1 turning points. That was the big thing that we wanted to see out of this first pretty long video.